I'm going to talk about something I'm very passionate about, which is really neonatal transfusion medicine. And today to focus on the what in neonatal transfusion medicine. What do I mean by the what? I mean, what's in this bag and how does what's in this bag impact the outcomes in our preterm infants? We've done a lot of work, and I think we've learned a lot about when we should transfuse, at least using hemoglobin as a guide through trials by the NICHD Neonatal Research Network, through work done by colleagues in Europe. And so I think we have good data today about at least how we should approach the when in transfusion. But looking forward, I think we need to really think about the what. What is actually in this bag and how does the what impact outcomes? And so that's what I'm going to talk to you about and make a case for why I think we really do need to think a lot more about the what in neonatal transfusion. So how many of you are blood donors here, have donated blood? So thank you for donating blood. So think about the last time you donated blood. You got up, had a cup of coffee, maybe you took some of the medications or vitamins or supplements that you take. Maybe you had breakfast or you skipped breakfast. Drove to the blood center, sat in the chair. They put a large bore IV in your antecubital fossa, and they drew a bag, a whole blood donation. And then that bag got split into red blood cells, which is what I'm going to focus on today. Got some of that was platelets. And then the bag actually of red cells went into some solution to prevent it from clotting. Commonly, citrate might be added to prevent that blood from coagulating. And then that supplier, maybe the Red Cross, maybe another local supplier, shipped that blood to your hospital, to the blood bank. And your blood bank then decided to maybe irradiate those red cells to prevent graft versus host disease. You might have then decided to take and order a blood transfusion. They took a little sample, they leukoreduced, took out the white cells from that, and they took that syringe and you used that and you gave one of your babies in your NICU transfusion. And the blood bank, to minimize actually being exposed to more than one donor, tried to say, hey, let's keep this bag and let's try to keep transfusing off of this bag multiple times. So they kept it on the shelf of the blood bank for a week, maybe 2 weeks, maybe up to a month. And then they took another sample from this to give for the next transfusion, maybe 3, maybe 4. And we've been thinking that every time you do that, that's actually the same, you're doing the same exact thing, giving the same exact product to an infant. Is that really the case? And then you look around at all of us, how different we are, how unique we are, and expecting that all of the red cells that we donate are going to have the same effect. And so I think that that's where really when we think about what's in a bag, there's been a lot of interest in the adult transfusion medicine community about how the impact of not when you transfuse, but what we transfuse, how that might impact recipients, particularly our preterm neonates and other populations. We have one of the most heavily transfused populations in all of medicine. And you're giving a large portion of often replacing the entire circulating blood volume over the course of a hospital stay with donor red cells. So I think there's an imperative for us to understand what's the impact of really understanding what's in the bag, and not only what's in the bag, but how does that impact recipient outcomes in those babies that you're transfusing? So what is that? So I touched on a little bit of that, but when you think about actually what's in that unit, there are a lot of things that can impact that. And you can start from really the donor, all the things we talked about from the people who are transfusing blood. But there's other things that we do. We store the blood, we irradiate. Most of the blood banks here in the United States will irradiate red cells before they transfuse into preterm infants, but there's a lot of units, some in Europe, that don't do this routinely. You might aliquot it into a syringe. There's some places that might wash those red cells. There's a lot of things that we do before we actually transfuse, and we put them into different bags. We might put them into bags that are CPDA1 or AS units. We then take all of that and we transfuse that into our patients. Now, this doesn't store as nice as fine wine. So one of the biggest areas that the blood banking community has been interested in is, if we sit this on the shelf, what happens to this blood as it sits for a week or 2 weeks or a month Or in some cases, what the FDA allows is up to 42 days. You can actually keep a unit of blood for up to 42 days in the blood bank. And how long a hospital allows blood to sit on the shelf is actually quite variable. There's some places that will expire units for preemies at 14 days, some places that allow it to stay because they can keep that single unit and keep transfusing for a long period of time and minimize exposure, but that means that the blood sits on the shelf for a long period of time. And we know from studies that actually individuals store blood differently. So there's some individuals that actually are what we would call superstores. They can donate blood and let it sit on a shelf and it doesn't change biochemically over that long duration of time. And other individuals whose blood stores poorly, where it actually has a lot of biochemical changes over time. And then you do additional things like you irradiate those red cells, and irradiation might further alter the red cells. They may make them more likely to leak what's inside of them. They may lead those red cells to break down, so you actually don't get the effect you hope for. So how can you actually test that? And how can you understand the what? Well, there's actually tools we have nowadays to really characterize all of the things I talked about into the unit. And the way you can do that is you can actually take a sample from the unit. You can run it. There's different tools you can use. One of the tools that's been widely used is actually looking at the metabolites. So this unit has a lot of these small molecules. You can actually take a sample of this. You can freeze it and then run it through a machine called a mass spectrometer. And as that little molecule runs through that machine, based on how heavy it is, the mass of it, the specific charge of those small molecules, you can try, in many cases, to identify the metabolites that are in the unit. And by understanding the patterns of metabolites and maybe how they change with storage and irradiation, you can get a sense of what's happening to this unit and how different certain units are to one another. So we became interested in this a number of years ago, and we started with actually looking at, we were transfusing units to preterm infants. We were giving these transfusions. We didn't really understand this common practice of irradiation. Many places are worried about graft versus host disease, particularly in our immunocompromised neonates. We leukoreduced the units to get rid of the white cells, but we also irradiated. What is irradiation, which is putting this through a machine that actually puts radiation through the unit to prevent and mitigate the risk of graft versus host disease, a machine that looks just like that. So we actually asked donors, this was done at Emory, we asked 6 donors to come in, volunteer, they came in and they donated some blood. And then we took the same unit that they donated, we split it into 2, and then we irradiated one of the units, and the other one was control. And then we stored it for 35 days, which is around the typical blood banking duration. And along the way at different time points, at 2 days, at 3 days, at 7 days, we took a little sample, we froze it, and then we took all of those samples and we ran it through a mass spec. And that allows you to characterize the entire profile of the unit, thousands of metabolites. In this study, about 12,000 metabolites that came out of that mass spec, that gives you a broad characterization of what's in this unit. And what we can then tell is, how do these metabolites, how do they look similar or different? How do they change by irradiation groups? How do they change over time? And so this is an example of the output from that. And when you think of, and when you look at this, you can just think of these as, each of these are patterns of thousands of metabolites that are kind of selected down to inform how similar or how different are these units. And so these are all very similar samples, and then they get very, very different as you look over here. So the units that are stored for about 2 to 7 days, regardless of whether they're irradiated or not, they look very similar clinically by looking at the metabolite profile. But then there's this big difference between 7 and 10 days, and then even as you store further, they start to get more and more separated, so that these metabolites start to tell you that these units are starting to look very different over time. And they're different not only with regards to how long they're stored, but also with regards to radiation. And maybe on the red side, maybe even at 7 days, you start to see these changes that are occurring in these metabolite profiles that characterize broadly all of what's in this unit, all of these molecules, things like glutathione and antioxidants and other metabolites, the characteristics of the red cells, all of those factors. And so this tells us that storing blood after being irradiated starts to really alter the characteristics of what's in this bag by about 7 days. Now, this is just looking at what's in the bag. It doesn't actually tie to what is the impact of what's happening to your preterm infants. So I think that then leads you to reflect, what are we trying to achieve when we actually order a blood transfusion? What are we actually trying to achieve? And I think for most of us, the goal here is we're trying to give the hemoglobin in this bag to our patients to increase their hemoglobin content so that that hemoglobin can pick up more oxygen and deliver it to tissues that need it. The brain, the gut. That's really what we're trying to do, is we're trying to improve the oxygen content of our neonates' blood because we think they're anemic and their hemoglobin's too low and they need more hemoglobin to carry enough oxygen to their tissues, their critical tissues. And so that's really the goal. We're trying to increase the hemoglobin of infants. And we hope, although I would say we don't always know, that by doing that, maybe we're improving their outcomes in various regards. Maybe we're reducing or mitigating some of the harms from being anemic, although really the trials haven't shown that giving more transfusions actually improve outcomes, that actually being a little bit more restrictive is as good as being more liberal with transfusion. But when you actually look at if that's what you're trying to achieve, you're trying to give a transfusion of this blood into patients, are you actually improving the thing you want to improve, which is oxygenation? We have a tool actually to assess that. One of the tools is near-infrared spectroscopy. And you can actually take and measure the regional saturation. It's not perfect, but it captures both venous and arterial oxygenation, and it can give you, especially within an infant looking at change over time, it can give you an idea of how a transfusion is impacting oxygenation. And your goal, if your goal is to give more blood to increase hemoglobin, that's going to lead to better oxygen content in blood. And if you do that, you're going to improve oxygenation. You can actually test that. And last year, a group out of Spain actually did that. And they specifically looked at that question we had, which was, how does storing blood after radiation impact the efficacy of transfusion in terms of oxygenation? And so they did this very unique study. They had these neonates. These were all preterm neonates that were monitored around transfusion. They put them on cerebral NIRS monitoring for a baseline before they got transfused. And then they randomized babies to actually blood that was from the same, they controlled for transfusions where they could control for the effect of the donor, where they actually split the bag into two, kind of like what we did. And both of the units, one was irradiated right before it was sent out from the blood bank to be transfused. The other came irradiated and sat on the shelf of the blood bank. So two intervention groups, one that had very little storage after it was irradiated for transfusion. That was the intervention group here. And the control group was blood that came irradiated from the blood supplier, sat on the shelf of the blood bank, and might have been transfused at 7 days, at 10 days. Why is that important? Because a lot of blood banks in the United States don't have irradiators in the hospital. So they rely on the blood centers to actually irradiate the red cells and then ship them to the blood banks, because having an irradiator is a lot of work. There's a lot of regulation around it because of the radiation risk and training, and so a lot of hospitals don't have that. So what they found is if you gave freshly irradiated blood, you actually had an improvement in cerebral oxygen saturation after transfusion. You had an increase from baseline that actually your oxygenation went up. And it stayed up for about 5 days. So those red cells you're transfusing presumably were carrying more oxygen and delivering to those tissues. And so you had this improvement in regional oxygen saturation, measured here cerebrally. And that stayed sustained because those red cells remained in circulation, presumably carrying oxygen to tissue. But what was striking is the other group, actually the control group, which actually went down after you gave a transfusion. If your whole goal is to increase and improve oxygenation, you actually achieved the opposite, which I think is very surprising. Why would you actually get worse if you gave a transfusion? If your goal is really to improve oxygenation, why does it actually go in the other direction if you're storing blood? There's about a 7-day difference in the storage after radiation of these two intervention groups. I think this tells us that maybe storage is important, especially when you think of it in terms of its effect after radiation on the efficacy of transfusion. Now, this difference was relatively small. It was only about 2 percentage point difference. So is this clinically important? I think that's uncertain. What are the clinical outcomes? Those were assessed. The primary endpoint here was oxygenation. But if you're transfusing and your goal is to improve oxygenation by increasing hemoglobin, I think you really do care whether you're actually achieving that short-term goal. And I think this is one example that highlights the importance of understanding the effect of the what, and what are we doing to these red cells before we transfuse. And so we actually just finished a cohort study, about 5 years of recruitment, where we took these samples from transfusions in our babies. We froze them, we ran metabolites, and we actually looked at something very similar, but instead of focusing on the brain, we focused on the gut. And we tried to understand what were the metabolites in the blood that predicted the response to oxygenation in the gut. And it turns out that many of those same metabolites in the pathways we showed that were impacted by radiation, that those same pathways, primarily the arachidonic acid metabolism pathway, really highly predict the response to transfusion. So maybe that arachidonic acid, if you think of the membrane of red cells and the lipid bilayer, this is going way back in training, that arachidonate is an important part of that might be an important marker of how good is what's in the bag. So I think this is one example. Really pleased when I saw this trial that was done about the importance of transfusion, and maybe irradiating and storing has some effects that influence the efficacy of transfusion, make blood less effective. See, the other aspect I'd like to think about is really thinking about the donor and how individual all of us are. And there are many characteristics that make us unique. I think one of the important characteristics that really does make us different is biological sex. And that we know has impacts on donation and blood donation, because hemoglobin varies very differently between males and female blood donors. The female blood donors have lower hemoglobin content in their donation, but there are other aspects of donor sex that influence the characteristics of blood. It turns out actually that female blood donors are more protected against the effects of irradiation of red cells. So if you take red cells and you look at that, female red cells are more protected against the effects of irradiation than male red cells. So if you think about that, and this has been a really a hot area and a focus in the adult transfusion medicine community of, does it matter if you get blood? Does the effect of the donor, maybe the age of the donor, the sex of the donor, do those things actually influence the effect of that? And so this was something that we really were interested in, and we looked at, where we took a cohort of babies who were transfused, and we looked at those infants who were transfused from blood from only female donors. So all of the transfusions they got were from female donors, or they were transfused from only male donors. And they got about 2 transfusions on average. And then we looked at, were the outcomes, the common morbidities of prematurity, different based on whether they got these very preterm infants received blood from only female donors or only male donors. And what the data showed is that there was an association with a lower risk, better outcomes in those infants that received blood from only female donors. And that association tended to increase in its protective effect as the age of the blood as the age of the donor increased. And so this was one of those where I would tell my mom that you're probably the best blood donor for preemies. I don't actually think we know that for sure. I think this data needs to be validated, and we're working on trying to validate this in other cohorts. But I do think that this highlights maybe the importance of what, and is there really an effect of donors on recipient outcomes? And so working with a hematologist, we've actually taken blood from donors, from males and females, and we've started to look at all sorts of aspects of those red cells. Not just how they differ in hemoglobin, not just the metabolites as showed, but actually things like oxygen affinity, which you can measure through P50, how deformable the red cells are. You can measure that through something called a cytometer. How viscous it is, and you can actually run it to look at blood viscosity. And there are a number of differences that differ, particularly in blood viscosity, which partly is due to the differences in the hematocrit or the hemoglobin content of the units that influence how blood flows, but also just differences in viscosity and deformability that really are quite different by donors and then differ over time. And so these biological differences in the characteristics of the red cells are different. And so one of the things we're interested in is trying to understand how do those differences in the characteristics of these red cells influence recipient outcomes? Because at the end of the day, if you're not achieving what you hope to achieve, which is improvements in oxygenation, I think we really have an imperative to understand that. And by understanding that, we might be able to improve that and potentially be more selective about particular donors. That's already being done today for plasma donors and plasma transfusion. Or maybe to understand further what are the ways we might be able to mitigate some of the effects of the characteristics of blood and the outcomes. So I hope that explains why I think we need to really think about the what in neonatal transfusion. And I do want to thank particularly the patients and families who've been part of the studies that I showed that we've recruited, as well as our collaborators and funding from NIH. So thank you very much.